Hello my dear students, hope you all are doing well and you are following the lessons also and doing the homework also regularly. Okay, so in the previous class we discussed about different types of functions, and with the help of graph we have calculated the domain and range of the function. You might have seen that when we are drawing the graph, it is easy for us to identify the domain and range. So today also we'll continue with that only. Some more questions we will solve to find out the domain and range. So write down the question. Find the domain and range of the following functions. Find the domain and range of the following functions. So in that, first one is f of x is equal to modulus of x minus 5. F of x is equal to modulus of x minus 5. So about modulus we discussed in the previous class. What we discussed about modulus function? Yes, we said modulus function is denoted by f of x is equal to mod x, and this is equal to x if x greater than or equal to 0, and it will be equal to minus x if x is less than 0. So if x is negative, less than 0 means already it is negative. And here we are writing one more negative sign. So negative into negative will become positive. So that's why a modulus function is always positive. It can be equal to 0, but it will never be negative. So here again we have to find out the domain and range. So domain means possible values of x and range means possible values of y. Possible values of y or possible values of f of x. So from here, can you tell me whether this value will become 0 when x is equal to 5? Correct? If x is equal to 5, we will get f of x is equal to 0. Take any other value. Suppose I am taking x is equal to any other number. X is equal to 1. Then what will come? F of x is equal to modulus of 1 minus 5. So that will be equal to modulus of minus 4. And modulus of any number is positive. So it will be equal to plus 4. In the same way, whatever number you are writing, its modulus either will be equal to 0 or it will be a positive number. It will not come negative. Whose value will not be negative? Value of f of x. In place of x, you can take any value. So first I have taken x is equal to 5. Then I took x is equal to 1. Take any other negative value. Suppose I am taking x is equal to minus 1. What will be the value of f of x? F of x will be equal to modulus of minus 1 minus 5. So that will be equal to modulus of minus 6. And modulus of minus 6 is plus 6. So x can take any value, but f of x always either it will be equal to 0 or it will be a positive number only. It will not take a negative value. So x can be any number. So we will write here domain of f is equal to R, because x can take any value. But range, when you are writing, in range we are not getting negative values. We are getting only positive values. So range will be equal to, it can take the value 0. F of x can be equal to 0. That's why I wrote here closed bracket. So it will be 0 or any number which is greater than 0. So 0 to infinity always. If modulus function is there in numerator, you can say it can take any real number and its range will be equal to 0 to infinity. Next question. F of x is equal to mod x minus 2. F of x is equal to mod x minus 2. Again, what you can say about possible values of x? X can be 0. Then it will be equal to, if x is equal to 0, we will get f of x is equal to modulus of 0 minus 2. So that will be equal to modulus of minus 2. And modulus of minus 2 is plus 2 only. Just to take any other value, x is equal to 5. Then what will come? F of x is equal to modulus of 5 minus 2. And 5 minus 2 is 3. Already it is positive. So you have to write positive value. Take any other value. Suppose x is equal to minus 3. Then what will come? F of x is equal to modulus of minus 3 minus 2. So that will be equal to modulus of minus 5. And modulus of minus 5 is plus 5. So again, f of x can take any value from 0 to infinity. It will give 0 when x is equal to 2. So x can take any value. So we will write down here, domain of f is equal to R. And range, always it will be positive real numbers. So range of f will be equal to from 0 to infinity. It can take the value 0. That's why their closed bracket is there. Is it clear? Okay. Now write down the next one. Third question is, f of x is equal to x square by 1 plus x square. F of x is equal to x square by 1 plus x square. Again, first we will check which value x will not take there. So normally it is coming in the form of rational numbers. So when we have rational number, we are checking one condition only. Denominator should not be equal to 0. So we will check that case when our denominator will be equal to 0. So if denominator equal to 0, then we will get x square is equal to minus 1. Meaning is square of a number is negative. Do you know any number whose square is coming negative number? No, because square of a positive number is positive and square of a negative number is also positive. So in real numbers, we don't have any number whose square will come equal to minus 1. So x square will not take the value minus 1. So here no restriction is there for the values of x. X can take any value. So we can write domain of f is equal to R. Domain of f is equal to R. Now we will check what will be the range. So for that we will substitute some values there. Just to check. Suppose if x is equal to 0. What will be the value of f of x? 0 divided by 1 plus 0. So 0 by 1 will be equal to 0. Any other number. X is equal to, suppose I have taken 2. Then what will come? F of x is equal to 2 square. That will be equal to 4 by 1 plus 4. That will be equal to 5. So we are getting 4 by 5. Which type of fraction this one? 4 by 5. Numerator is smaller than the denominator. So obviously it is a proper fraction. And a proper fraction always lies between 0 and 1. So obviously its value will be less than 1. Correct? Any other value. Suppose I am taking a negative number. Minus 3. Then what will come? F of x is equal to x square. So that will come here 3 square. 9 by 1 plus 9. 9 by 10. So again we are getting a proper fraction. So proper fraction means its value will be less than 1. Any number. Now suppose I am taking a decimal number. Suppose decimal number we are taking 0.5. 0.5. So when x is equal to 0.5. F of x is equal to what will come? 0.5 square. So that will be equal to 0.25 by 1 plus 0.25. So we will get here 0.25 by 1.25. Again, doing with decimals will be difficult for us. So first what we can do? We can remove the decimal. So we can multiply it by 100. Why by 100? Because after the decimal we have 2 digits. So when we will multiply, we will get here 25 by 125. Again, you can check numerator is smaller than the denominator. So its value also will be less than 1. So we checked for 0. Then we checked for positive numbers, real numbers, decimal number. If you want, you can check for irrational numbers also. Suppose x is equal to root 2. Then what will be the value of f of x? Root 2 the whole square. That will be equal to 2 by 1 plus 2. So again we are getting 2 by 3, which is less than 1. So what we got there? When we have taken x is equal to 0, we got f of x equal to 0. And rest all the values are less than 1. So we will write down a range of f. We know it can take the value 0. So it can take the value 0 and then 1. Whether 1 will be open or closed. The value always it is coming a proper fraction, and a proper fraction is always less than 1. So it will not take the value 1. So what we will write here? Closed bracket. Except 1, it can take any other value which is slightly less than 1. It can take the value 0.99998. Any other value which is slightly less than 1. So range will be equal to closed interval 0, 1. 1 is open. So these type of intervals are called half open or half closed. I think this one is clear to you. Okay. Now write down the next question. F of x is equal to x square minus 9 by x minus 3. F of x is equal to x square minus 9 by x minus 3. So again our function is given in terms of fractions. So denominator should not be equal to 0. So for which value of x it will be equal to 0? Yes, when x is equal to 3. So except 3, x can take any other value. Correct? So we will write here domain is equal to. Domain of f will be equal to all real number except which number? Except 3. So domain is equal to r minus 3. Now we will check what will be the value of f of x. So to calculate f of x, first we can just simplify it. Here x square minus 9. 9 is the square of which number? 3. So it can be written as x square minus 3 square by x minus 3. Do you remember any identity by seeing the numerator? Yes, it is in the form of a square minus b square. So that will be equal to a plus b into a minus b. Then we will get here x plus 3 into x minus 3 divided by x minus 3. So here x minus 3 and x minus 3 will get cancelled. We will get here f of x is equal to x plus 3. So now by seeing this expression, we have to find out f of x will not take which value. So what is the restriction for x? X will not take the value 3. Except 3, x can take any other value. So here also we have to check when x is equal to 3, what will be the value of f of x? When x is equal to 3, we will get f of x is equal to 6. But already when we wrote the domain, that time we wrote x will not take the value 3. So if x is not equal to 3, then f of x also will not take the value 6. Any other value x can take. So f of x also can take any other value except which one? Except 6. Why? Because x will not take the value 3. So if x is not equal to 3, then f of x also will not be equal to 6. Except that f of x can take any other value. So we will write here range of f is equal to all real number except which number? 6, because x will not be equal to 3. This method is clear? Okay. Now write down the next one. F of x is equal to 4 minus x by x minus 4. F of x is equal to 4 minus x by x minus 4. So again, can you tell me what will be the domain? What will be the domain? Yes. I think, have you wrote the domain? What will come? All real number except which number? Except 4. Why 4 we wrote there? Because when we will equate x minus 4 to 0, we will get x is equal to 4. So except 4, x can take any other value. So domain of f will be equal to r minus 4. Now we have to find out the range of f. So for that, two methods are there. First one, some values we can substitute. So if x is equal to 0, what will be the value of f of x? Substitute 4 minus 0, 4 by 1 minus 4. So that will be equal to minus 4. It will be cancelled. We will get here minus 1. Any other number. X is equal to 3. Then f of x is equal to 4 minus 3, 1 by 3 minus 4, minus 1. So again we are getting here value equal to minus 1. Any negative number, x is equal to minus 4, because x is equal to 4 only is not possible. Minus 4 we can take. Then it will be equal to 4 minus 4 by minus 4 minus 4. 4 minus into minus will be equal to plus. Then 4 plus 4, 8 by minus 4 minus 4, minus 8. So again these two will get cancelled. We will get the answer is equal to minus 1. So whatever values of x you are taking, value of f of x is a single number. What is that number? Minus 1. So range of f will be equal to, it contains only one element, that is minus 1. So the set contains only one element is called which set? Singleton set. So range of f will be a single number minus 1. So either you can use this method, or here our f of x is given. So just to check in these two numbers, only a difference of negative sign. So if I will take a negative sign common from numerator, what will happen then? Positive will become negative and negative expression will become positive. Then we will get here x minus 4 by x minus 4. Then x minus 4 and x minus 4 will get cancelled. We will get f of x is equal to minus 1. So here there is no x here. So whatever be the value of x, f of x will be a constant number, and that constant is equal to minus 1. So again in this case also we are getting range of f is equal to minus 1. So now I think these concepts are clear to you, how to find out the domain and range. Okay. Now we will do some extra questions. Some more questions related to relations and functions only. Write down question number 2. Let a is equal to, let a means set a, let a is equal to 8, 10, 12, 15, and let f maps from a to n be defined by, let f maps from a to n be defined by f of n is equal to, be defined by f of n is equal to the highest prime factor of n. F of n is equal to the highest prime factor of n. The highest prime factor of n. Question is, find the range of f. Find, all of you do these works with me only, Find the range of f. So here already given the function f maps from a to n. Maps from a to n means when we will write the ordered pair, the element we will take, the first element we will take from the set A, and according to the relation f of n is the highest prime factor of n. So we will find out that natural number, because n denotes the natural number. So first the second one, f of n, which we will write, that will come in the second pair when we are writing in pair. Okay. So now I am taking first the set, from the set A we have to take the first element 8. So I am writing from the ordered pair, the first element is 8 and relation is defined in A. F of n will be the second element in the ordered pair. So to find out the second element, this is the relation given. So in that I am taking first n is equal to 8. So according to the relation, what I have to find out? The highest prime factor of 8. The highest prime factor of 8 I have to find out. So for that, first shall I write what are the factors of 8? Yes, what are the factors of 8? 1, then 2, then 4, and then 8 itself. So we have these factors. Out of this one, which is the highest prime factor? I think in this number only 2 is a prime number. So the second element will be equal to 2. So in ordered pair, our first element is 8 and second element is 2. In the same way, now we will take the next element from the set A, f of 10. So according to the definition, what we have to find out? The highest prime factor of 10. So first I am writing the factors of 10. What are the factors? 1, then 2, 5 and 10. These are the factors of 10. Out of this one, these two are prime numbers and the highest prime number is 5. So the element 10 is related to 5 by this rule which is given in the question. Then next we will take 12. First element is equal to 12. Write down the factors. 1, 2, 3, 4, then 6 and then 12 itself. Now here also we will check what is that highest prime factor. We have two numbers here which are prime. And out of that the greatest number is 3. So the element 12 is related to 3 by this rule. And now one more is left, that is 15. So F15. Write down the factors of 15. 1, then 3, then 5 and then 15 itself. Correct? Now here again 3 and 5, two numbers are there and the greatest number is 5. So 15 is related to 5 by the rule which is given. So now write down in ordered pair. We are getting f is equal to, we are getting the function f as, the first element we have 8, 2, 10, 5, 12, 3 and 15, 5. And the question asked is find the range of f. So when we are writing in ordered pair, we know the second element is called the range of f. So just write down what are the second elements we have. Range of f is equal to the set of all second elements. So we have 2, 5 is there 2 times, so 1 time only we have to write. So we have range of f is equal to set 2, 5, 3. So I think this is clear to you. Okay. Now write down the next question. Question number 3 is, let f be the subset of, let you write down small letter f. Let f be the subset of z cross z. Let f be the subset of z cross z. Z cross z means Cartesian product. Z means set of integers. Subset of z cross z defined by f is equal to set of all ordered pair AB, A minus B, where A and B both belongs to Z. Now question is f a function from Z to Z? Now here you don't have to prove it is a function. You have to check whether it is a function or not. Is f a function from Z to Z? Just justify your answer. We have to find out whether it is a function or not. And you don't have to prove here. So again, when we don't have to prove anything, we can give some example. So the first one you can check. Here the element should be written in this way. The first one is in the form of multiplication. A and B we have to choose our value only. So here multiplication. So just check how we will do this question. We can take any number whose multiplication we are knowing. So suppose AB is equal to 12. Two values we can check. AB is equal to 12 we are taking. I am taking the first element as 12. Now can you tell me what are the two numbers whose multiplication will give you 12? So one condition is 3 4s are 12. And the other one is 2 6 are 12. Anything we can take. So suppose first I am taking A is equal to 3 and B is equal to 4. A is equal to 3 and B is equal to 4. Then according to the relation, what will come? First one, AB. So 3 into 4 is 12. And here what we will get? 3 minus 4. So according to the rule, 12 is related to minus 1. Now I am taking this value, 2 and 6. Then what will come the ordered pair? 12, comma. I have taken A is equal to 2 and B is equal to 6. Then 2 minus 6 and 2 minus 6 will be equal to minus 4 according to this rule. Correct? So what we are getting? 12 is related to minus 1 also and 12 is related to minus 4 also. So this is not a function because according to the definition of function, the first element should be related to a unique element. It should not be related to two different elements. So just write down there. It is not a function. It is not a function. Okay. Now write down question number 4 is let R be a relation from capital R, capital R set of real numbers. Let R be a relation from n to n. R is a relation from n to n. From set of natural numbers to natural numbers defined by R is equal to set of all ordered pair A comma B such that A comma B belongs to n and A is equal to B cube. A is equal to B cube. Now question is, are the following true? Are the following true? So in that first question is, A comma A belongs to R. You have to check whether they are true or not. For all A belongs to N. Second we have to prove A comma B belongs to R implies B comma A belongs to R. We have to check whether they will satisfy all these properties. And third one we have to check A comma B belongs to R and B comma C belongs to R implies A comma C belongs to R. These are the things which we have to check. And the relation is given in this way. A is equal to B cube. A is equal to B cube meaning first element is the cube of the second element. First element is the cube of the second element. Now only that element will come which satisfy this rule. What is that rule? First element is the cube of the second element. So first we have to check whether A comma A belongs to R. A comma A belongs to R means they should satisfy this one. A and A means same element. So the first element is the cube of the second element. So just check there. If I will take A is equal to 1, then what will be A cube? A cube also is equal to 1. So obviously 1 comma 1 is belongs to R. Correct? Okay. Now I am taking any other value. A is equal to 2. Then what will come? A cube. 2 cube is equal to 8. What I have taken? A is equal to 2. Or first element is the cube of the second element. So I am taking B is equal to 2. Then what I am getting here? A is equal to 8. So I am getting here 8 comma 2. But according to the relation, same element should be related to same element. We know 2 cube will not be equal to 2. Correct? So 2 comma 2 will not belongs to R. Just write down here. 2 comma 2 does not belongs to R. Therefore, this is not true. A comma A means same element is related to same element by this rule. Meaning what? The element is itself its cube. The element is equal to its cube. For 1 it is true because 1 is equal to 1 cube. But 2 is not equal to 2 cube. Therefore, this relation is not true. Clear? Okay. Now we will check the second one. Second one, what we have to prove? We have to take that element which satisfy the relation. A comma B belongs to R. Relation was in this way. A is equal to B cube. So if you will write in ordered pair, first A and then B should come. Okay. So first we have to take that, any number we can take. That number which satisfy this relation there. So suppose I am taking B is equal to 2. Then obviously A is equal to 8 will come. So 8 comma 2 belongs to R. Correct? 8 comma 2 belongs to R. Now we have to check whether B comma A is also belongs to R. So B comma A will belong to R if B comma A will satisfy the relation. What is that relation? Just write down. If you want, just write here. B comma A will belongs to R if the first element is the cube of the second element. What we have taken here? B is equal to 2 and A is equal to 8. So 8 comma 2 belongs to R. Now if we will reverse the order, 2 comma 8, whether it belongs to R or not. First element is the cube of the second element. Is it true? The first element 2, whether 2 is the cube of 8? No. So 2 comma 8 does not belongs to R. Therefore, the second property is also not true by the rule which is given. First element is the cube of the second element. Okay. Now we will check the third one. Here we have to check. So you can take any example there. Now first one, A comma B belongs to R. So any number we can take. A comma B. So suppose I am taking A is equal to 2, B is equal to 3 and C is equal to, we will check there, A comma. So first one is A comma B belongs to R. Meaning is first element is the cube of the second element. So I am taking the first element, suppose B is equal to 8 I am taking because here we want it is the cube there. So I am taking B is equal to 8 and here A is equal to what will come then? Cube. Correct? So if B is equal to 8, so just take B is equal to 8. Why I have taken 8? Because if A comma B belongs to R means A should be equal to B cube. And B comma C belongs to R means B should be equal to C cube. So here B should be equal to C cube. So B should be a perfect cube. So that's why I have taken B is equal to 8. So if B is equal to 8, what will be the value of A? A is equal to B cube. So 8 cube is 512. So this belongs to R obviously. Then B is equal to C cube. I have taken B is equal to 8. So obviously C will be equal to 2 because 2 cube is 8. These two belongs to R according to the rule. Now we have to check whether A comma C also belongs to R. So to prove this one, what we will check whether the first element that is A is equal to C cube. Okay. Now what is our value of A? 512. And value of C is 2. So whether this one, whether 2 cube is equal to 512? No. So this does not belongs to R. So R will not satisfy any of the property according to the rule which is given. What is the rule given? The first element is the cube of the second element. So all these are not true. Okay. Now write down question number 5. Question number 5 is, just write down, let f, set f is given, a function only, 1 comma 9, minus 1 comma minus 1, 0 comma 4, minus 2 comma minus 6. Be a function from z to z. Let f be a function from z to z defined by f of x is equal to ax plus b. Defined by f of x is equal to ax plus b for some integers a and b. For some integers a and b, find a and b. We have to find out what is the value of a and b using the given information. Now it is a function already given. So in function, when we are writing the ordered pair, we are taking the first element. First element denotes the value of x, correct? First element denotes the value of x and second element denotes the value of f of x. So here f of x is equal to ax plus b given. So out of this value, any value you can take. So we can take that value in which our calculation is easy. So here you can check this one. What we are getting? The first element, if x is equal to 0, we are getting the second element f of x is equal to 4. So just substitute in this one. Substitute x is equal to 0 and f of x is equal to 4. Then what will come? 4 is equal to a into 0 plus b. So obviously a into 0 is 0. So we are getting from here only b is equal to 4. So now we got the value of b as 4. Now we want the value of a also. So any value you can take. So I think this one we can take. So no negative numbers are there. Okay. So according to that, if x is equal to 1, f of x is equal to 9. Now substitute. X is equal to 1 and f of x is equal to 9. Then what will come? F of x is 9 is equal to a into 1, a plus b. Now already we know the value of b. So substitute here. Then we will get a plus 4 is equal to 9. So from here we will get a is equal to 9 minus 4. So that is equal to 5. So we got a is equal to 5 and b is equal to 4. So whenever it is given in this way and function is f, the first element is the value of x and the second element is the value of f of x. So I hope this method is clear to you. Okay. So now we will do the next question. Write down question number 6. Question number 6 is written. The relation f is defined by f of x is equal to 2x, 0 less than or equal to x less than or equal to 2, and this is equal to x plus 2 if 2 less than or equal to x less than or equal to 4. The relation g of x is defined by the relation g. You can write the relation g is defined by g of x is equal to 2x plus 5, 0 less than or equal to x less than or equal to 2, and this is equal to 3x, 2 less than or equal to x less than or equal to 4. These are the two relations given. Now we have to prove. Write down. Show that f is a function and g is not a function. Show that f is a function and g is not a function. So here conditions are given. When the value of x lies between 0 and 2. Then it is the function we have to take is equal to 2x, and then when its value is between 2 and 4. So at present we are taking only the integers there. Okay. So shall I write directly the ordered pair? Okay. If x is equal to 0, here what are the values x can take? From 0 to 2. So we have 0, 1 and 2. So when the values are 0, 1 and 2, we will take this function. And when values are equal to 2, 3 and 4, we will take this function. Okay. So now, if x is equal to 0, f of x is equal to 2x. So 2 into 0 will be equal to 0. So if x is equal to 0, f of x also equal to 0. Next one, if x is equal to 1, then f of x is equal to 2 into 1, 2. Then when x is equal to 2, f of x will be equal to 2 into 2, 4. So 2 comma 4. Now we will check here. X plus 2. When x is equal to 2, then we will get here f of x is equal to 2 plus 2, 4. So again we are getting here 2 is related to 4. When x is equal to 3, we will get 3 plus 2, 5. When x is equal to 4, we will get 4 comma 6. So first we can write down the element and then we can check whether it is a function or not. Now in the same way we will write for g also. So here again it will take the values from 0, 1 and 2 and here 2, 3, 4. So substitute x is equal to 0. What will come value of g of x? 5. Correct? 0 comma 5. Then when x is equal to 1, 2 into 1, 2. 2 plus 5, 7. So 1 comma 7. Then when x is equal to 2, 2 into 2, 4. 4 plus 5, 9. So 2 comma 9. Now here, when x is equal to 2, we are getting 3 into 2, 6. So 2 comma 6. When x is equal to 3, we will get 3 comma 9. Then when x is equal to 4, we will get 4 comma 12. So here are the elements which we have. So just to check, 0 is related to 0 only. 1 is related to 2 alone. 1 is not related to any other element. Here also same elements are there. 2 is related to 4 only. So all the elements, all the first element are related to a unique element. But here in this one you can just check. 2 is related to 9 and 2 is related to 6 also. The first element is related to two different elements. So G is not a function. The reason you can write down there because 2 is related to 9 and 2 is related to 6 also. So in this way we can justify why it is not a function. So I think these concepts are clear to you. These all questions are, these patterns are given in your textbook, miscellaneous exercise. So I explained you how to do all the questions and all of you write down your homework. Your homework is miscellaneous exercise. Miscellaneous exercise chapter 2. Chapter 2. In chapter 2, question number 1, 5, 8, 9, 11 and 12. Chapter 2, in that you have to do question number 1, 5, 8, 9, 11, 12. Rest all the questions in between. Some questions are related to domain and range. That all I gave you previously. Only question number 7 we are not doing because that is related to addition, subtraction of fractions. And this year that topic is avoided. So do the questions and in case of any doubt you can ask. Thank you.